We're now required for 5.3 to write an expression for the equilibrium constant Kc for the reaction. So let's have a look what we've got. So we've got, on the right hand side, we've got the diester, and we've got one of those, so that's square brackets around that, and we've got two waters, so it's H2O square brackets squared, divided by ethanoic acid in square brackets squared, and divided also by the ethane dioic acid in square brackets as well. So that will now look like that. It says you don't need to measure the volume for concentration, you can just use moles. Well, moles is moles that you don't need to turn it into concentration, you can leave it as moles rather than dividing by volume, because if I divide by the volume once, twice, three times to turn these molar amounts, these moles, into concentration by dividing each of them by the volume, I'd be dividing 3 times here and 3 times here. In other words, the volumes cancel because there's equal number of moles on the left and right of the equation. So if we look back, there are 3 moles, 2 and 1 on the left hand side of the equation, 3 moles on the right hand side of the equation. So if I was converting moles into volume, I'd be dividing by 3 volumes on the top and 3 volumes on the bottom, and it would just, the volumes would just cancel out. A different mixture of ethanoic acid, ethane, 1,2-diol and water were prepared and left to reach equilibrium, and I've now got the concentrations of each. I need to calculate the concentration of this CH3COH, and I've been given an equilibrium constant. So this is just maths where I'm putting numbers in. So 6.45 is the equilibrium constant here. I've got the concentration of the diester, 0.802, multiplied by the concentration of water squared, 1.5 squared, multiplied by, divided by CH3COH concentration squared, I don't know that one, and multiplied by 0.264, which is the concentration of the ethane 1,2-diol on the bottom. If I multiply this out then, and I then rearrange the equation, so 6.45, I've multiplied this out, 0.802 multiplied by 1.5 squared is 1.06, and then I have multiplied, so taken this from the bottom on the right hand side and moved it to the top on the left hand side, and then I've multiplied that out, 1.7, divided them by, swap them over, so 1.06 divided by 1.7, which equals 0.624, equals the concentration of ethanoic acid squared. Square root it, 0.789 is the concentration of the ethanoic acid. And I've done it to 3 significant figures because the other values are to 3 significant figures also.